incredible. Okay, gonna have lots of inventions along the way.
It's been nearly 3 years since the James Webb Space Telescope began its science mission, unfolding its golden mirrors and turning its gaze toward the origins of time. In that short span, it has peered through cosmic dust, unveiled hidden stars, and captured light that has traveled for over 13 billion years. But more than just stunning images, Webb offers something deeper. Answers to the fundamental questions of our existence. How did the universe evolve from chaos to cosmos? And are we truly alone? This isn't just a telescope. It's a time machine, a cosmic archaeologist, and perhaps the most ambitious project humanity has ever launched into space. This is the story of what Webb has discovered so far. The James Webb Space Telescope was designed to do what no other telescope could: see the invisible. Operating primarily in infrared light, it detects wavelengths too long for human eyes to see, but perfect for peering through dust clouds and into the early universe. One of its first stunning feats was imaging the Sombrero Galaxy. While Hubble showed a glowing halo, Webb's mid-infrared instrument revealed something else entirely: a complex network of inner disks and fragmented clumps, each a puzzle piece of galactic evolution. These aren't just pretty images. They're scientific maps, tracing the fingerprints of time. By unveiling details once hidden behind veils of dust, Webb has opened new frontiers in galactic archaeology. It's like lifting the fog off a landscape and finally seeing the mountains beneath. This is more than better vision. It's a redefinition of what we can even call visible. One of the most unsettling early discoveries came when Webb observed a black hole consuming matter in a dwarf galaxy, dating back just 1.5 billion years after the Big Bang. This black hole appears to be growing far faster than expected, possibly exceeding the Eddington limit, the point where radiation pressure should counterbalance the pull of gravity. It's like finding a skyscraper in a medieval village. The data suggests either that black holes can grow much faster than current models predict, or that the conditions in the early universe allowed for mechanisms we don't yet understand. Could this be a primordial black hole formed moments after the Big Bang? Or does it reveal flaws in our understanding of black hole physics and galactic evolution? Thanks to Webb, we're now able to ask these deeper questions with greater clarity. And one day, we may rewrite the rulebook entirely. Vega, one of the brightest stars in our night sky, located about 25 light-years away, has long been a focus for astronomers searching for clues about planetary formation. Hubble showed us a disk of fine dust, typically a hallmark of a young star's ability to form planets. But Webb added a twist. Its infrared vision revealed that Vega's dust disk is unusually smooth. Too smooth, in fact. There are no gas clumps, no gravitational tugs, no signs of planetary building blocks. Despite all the material for planets, there are no signs of building, no gravitational disturbances, no young worlds forming. Vega's surroundings suggest it may be a planetary desert, a bright star surrounded by silence. This challenges the assumption that dust always means planets, and opens up new mysteries about the variety of solar systems that might exist. Galaxies are not solitary structures drifting peacefully through space. They are dancers, spinning, colliding, merging, and morphing over billions of years. One of Webb's composite images, made in tandem with Hubble and released in 2023, showcases two galaxies caught mid-collision. Located 465 million light-years away, this pair, a spiral and an elliptical galaxy, are entwined in a gravitational tug-of-war. The spiral's arms are stretched and distorted, while streams of dust trigger waves of new star formation. Mergers like these are not acts of destruction, but of transformation. The chaos leads to creativity, as gravity mixes raw material into entirely new galaxies. By capturing these events in infrared, Webb helps us understand how the universe evolves not just through order, but through collision and chaos. At first glance, Webb's observation of 29P/Schwarzmann-Wachmann, a Centaur comet orbiting between Jupiter and Neptune, might seem like comic relief. Scientists even joked that the telescope had captured a space fart. But behind the humor is a serious scientific treasure. Webb's near-infrared spectrograph detected jets of carbon dioxide and carbon monoxide bursting from the surface, evidence of internal heat causing volatile materials to erupt. These outgassing events are windows into the chemistry of the early solar system. They also raise profound questions. If such chemical compounds exist on icy objects today, could similar processes have delivered the building blocks of life to Earth or to other worlds? 29P might be small, but its chemical emissions are a clue to one of the biggest questions of all: how life began. One galaxy in particular, spotted by Webb, breaks all the rules. Its gas, hydrogen, helium, and trace elements glows brighter than the stars themselves. This is incredibly rare. Normally, it's the stars that illuminate a galaxy, but here, it's the gas that shines, like a candle burning from the inside out. Scientists believe this could be a transitional phase, a moment when a galaxy shifts from the chaotic energy of starbirth to the structured calm of maturity. Observing this stage in real time gives us new insights into how galaxies evolve over billions of years. Thanks to Webb's precision, we can now spot these short-lived evolutionary moments, chapters of cosmic history that Hubble may have missed entirely. Webb's exploration hasn't just looked outward, it's also turned inward. When pointed toward the very fringes of our Milky Way, it uncovered something unexpected. The extreme outer regions of our galaxy, long thought to be calm and uneventful, are actually brimming with activity. Webb revealed massive, newly forming stars embedded within molecular clouds at the galactic edge. These are regions typically difficult to observe due to distance and dimness. But now, they've become laboratories of stellar evolution. What's fascinating is the implication. Star formation isn't just a central galactic phenomenon. It thrives even in the cold outskirts, where cosmic conditions are drastically different from our solar neighborhood. This challenges the idea that galactic growth only happens from the inside out. Webb shows us it also flourishes from the edge inward. Perhaps the most jaw-dropping revelation from Webb came when it spotted galaxies that should not exist. Located just 500 to 700 million years after the Big Bang, these galaxies are gigantic, far too massive and luminous for such an early stage in the universe's life. They're so large that they threaten to topple our standard model of cosmology. How could galaxies grow so quickly? Were stars forming faster than we thought? Or are we seeing something else? Perhaps black holes at their centers, making them appear artificially bright. One possibility is that these galaxies host active galactic nuclei. Supermassive black holes emitting intense radiation that inflates their brightness. The light from these active galactic nuclei could be distorting our perception of the galaxy's size and maturity. Either way, these ancient giants force us to reconsider how quickly structure emerged in the early universe. We may have to revise the timeline of everything. To bridge our view from these early galaxies to closer worlds, let's now shift our attention to exoplanets and the strange frozen frontiers Webb has revealed. Webb hasn't just looked deep into the past. It's also zoomed in on nearby stars and their planetary companions. One of its most astonishing finds is a gas giant orbiting just 12 light-years away, with a surface temperature estimated at just under 2 degrees Celsius, or about 35 degrees Fahrenheit. That makes it one of the coldest planets ever directly imaged. Even stranger is a tidally locked exoplanet, where one side always faces its star, while the other remains in eternal darkness. You'd expect the day side to be hottest, but Webb's infrared observations showed the warmest region was along the twilight zone, the boundary between day and night. This hints at atmospheric winds or even magnetic field effects redistributing heat in unexpected ways. These insights were only possible thanks to Webb's precision spectroscopy tools, allowing scientists to decode temperature gradients, chemical compositions, and cloud structures in alien atmospheres. As Webb continues scanning these planetary systems, we may soon learn not just how planets form, but whether any might support life. Using its unparalleled infrared sensitivity, Webb has examined young star systems in the process of forming planets, and what it's found is astonishing. In several protoplanetary disks, Webb has detected clear signatures of water vapor, carbon dioxide, methane, and even more complex organic molecules like alcohol. These ingredients are the raw materials for life, and they appear not in just one place, but scattered across the galaxy. Most thrilling of all, water vapor was found in the habitable zone of a distant star system, the region where rocky planets could retain liquid water on their surfaces. It's the first time such a detection has occurred this early in a solar system's formation. It doesn't prove there's life out there, but it does confirm something equally profound. The building blocks of life may be everywhere. Some of Webb's most breathtaking images come not from new discoveries, but from seeing the familiar in a completely new light. Take the Cartwheel Galaxy. Once seen as a chaotic ring left by a galactic collision, Webb's imagery revealed intricate waves of star formation spiraling outward like ripples in a pond. Or the cosmic cliffs of the Carina Nebula, where stellar winds carve dramatic ridges in clouds of hydrogen gas. Webb's images allow us to watch stars being born, jets shooting out from infant suns, and entire systems forming before our eyes. And then there's Neptune. For the first time in over 30 years, we can clearly see its icy rings and distant moons like Triton, thanks to Webb's ability to detect heat signatures invisible to human eyes. These once fuzzy dots are now vivid structures glowing against the dark. Beyond individual images and phenomena, Webb is revealing the universe's larger blueprint. It's mapping the cosmic web, vast filaments of galaxies stretching across the universe, shaped by gravity over billions of years. It's documenting star birth, planetary collisions, and supernovae that seed the cosmos with life-giving elements. It's even spotted high-speed jets from baby stars, strange magnetic auroras on brown dwarfs, and carbon-rich surfaces on icy moons like Europa. Each discovery is a thread, and together they weave the story of everything. Webb wasn't built just to look farther. It was built to understand deeper, and in doing so, it's helping us understand ourselves. As we stand beneath the night sky, it's easy to feel small. A single mind on a spinning rock orbiting a common star. But the James Webb Space Telescope reminds us that we are part of something far more vast, ancient, and intricate than we ever imagined. In just 3 years of science operations, it has shown us galaxies we never knew existed, planetary systems we never dared hope to find, and evidence that life's essential ingredients may be scattered throughout the stars. And it's not done. In the years to come, Webb will continue to reshape our understanding of the universe and ourselves. Because in the end, every image it captures is not just a snapshot of space, it's a snapshot of where we've come from and where we might be going. This has been a journey to the edge of time, powered by the most powerful space telescope ever built. Thank you for watching. Don't forget to subscribe and share, and until next time, keep looking up.